Now here's an integral to do that's a pretty tough integral. So let's do it. We know that when we have something like the 1 plus x squared here, we're going to use a trigonometric substitution, okay? And according to the notes I gave you in class, the substitution we're going to use is x equals 1 times the tan of theta, or just tan of theta. And remember, when we're substituting, whether it's a trig integral or any other kind of integral, we always want to follow that up with the derivative. The derivative of the tan is the secant squared of theta. Okay, and also, because this is an indefinite integral, I'm going to draw a triangle. It's not a very good looking triangle at all. But anyway, the tangent of theta is x, which we can write as x over 1, opposite over adjacent. And the hypotenuse then would be 1 plus x squared, square root of 1 plus x squared by the Pythagorean theorem. Okay, so now we are ready to not only integrate, but also at the very end, when we go back from theta to x, we've got our triangle in place. Okay, so we're going to substitute, and we will have the square root of 1 plus the tan squared of theta over the tan of theta. And we're going to substitute for dx. Oops, forgot a d theta here. So dx is going to be secant squared theta d theta. Very important that you don't forget to substitute for dx. Okay, so let's keep simplifying the trig. So 1 plus tan squared is secant squared theta. And out here we have secant squared theta over the tan of theta. And a little bit more here, we're going to have the secant cubed of theta over the tan of theta. Okay, now at this point I got to tell you that I tried an awful lot of things that didn't work, and that often happens with trig integrals. So you'll see the result of all those things that didn't work. I'm not going to show them all to you, but what did work is, first of all, changing all these, or the secant and the tan, to sines and cosines. Okay, so I'm going to just continue on here. Now the secant is 1 over the cosine, so the secant cubed is 1 over the cosine cubed. And remember, the tangent is the sine over the cosine, so when we divide by the tangent, when we divide by the sine over the cosine, that's the same as multiplying by the cosine of theta over the sine of theta. Okay, and then we'll have this cosine will cancel, leaving us with cosine squared here. Okay, so we'll have 1 over the cosine squared times 1 over the sine. And if we go back to our cofunctions, 1 over the cosine, or not really the cofunctions, so 1 over the cosine squared is the secant squared, and 1 over the sine is the cosecant. So, okay, so we did a lot of trig to get down to this basic integral that we now have to do. Okay, now what we're going to do here, I've got a couple things that I'm going to use later on, so let's get these out of the way for the time being. Okay, so what we're going to do now is we're going to use integration by parts here. Now look, we know that the derivative of the tangent is a secant squared, so we're going to set this up so that u is the cosecant of theta and dv equals the secant squared of theta, so that when we integrate the secant squared, we get the tangent. Okay, and I did that because I know that the derivative of the tangent is the secant squared. Okay, that's easy to integrate, and the secant squared is in my integral. Du, let's see, the derivative of the cosecant. Now you would have to refer to your basic forms, but the derivative of the cosecant, that's why I have it down here, is minus cosecant of x tan x. Okay, so let's write that down. Might have to move some of this, so let's move this over. And I've got minus cosecant theta. Was it tan theta? Let me double check. Cotan theta. Okay. Okay, so now I'm going to use integration by parts. So it's going to be u times v, so we're going to have tan theta cosecant theta minus the integral of v du, and we have minus a minus, so I'm going to write plus, and we'll have the integral of the cosecant of theta times the cotan of theta times the tangent of theta d theta, and oh geez, I keep forgetting my d thetas. Okay, and we got to move this down again. All right, now the cotan times the tan is just 1, right? Because cotan is 1 over tan. This is just 1 over the tangent of theta times the tangent of theta. Those cancel and give us 1. So what we have left here is that our integral of secant squared cosecant of theta equals the tan of theta cosecant of theta plus the integral of the cosecant of theta d theta. Now this will go to our basic forms. Our basic forms have all the trig functions, the integrals of all the trig functions. So here it is. I took this right out of the reference pages in our book. And so we have tan theta cosecant theta plus the natural log of the cosecant of theta minus the cotan of theta plus c. Okay, that looks good. All right. Now, what were we integrating to begin with? The square root of 1 plus x squared over x. Okay, and this, of course, is in terms of x, and our answer here is in terms of theta. So we have to convert all those thetas and those trig functions back into x. So we're going to use a triangle for that. Okay, so I'm going to, actually, I think I'm going to, well, let's see. I think I'm going to go to another page. Bear with me a minute here. So I'm going to have the integral. Let's have what we started with initially, 1 plus x squared over x dx. Okay, and let's bring let's bring our answer so far over there. Okay, so I'm going to copy that and bring it over here. Okay, that's what we got in terms of theta, and that, remember, was with the substitution x equal tan theta, dx is secant squared theta, and let's take all this with us too. So copy that and bring it over here, and maybe I'll put that right there. Okay, good. We're in good shape now. Okay, now, actually, I'm going to bring this triangle. Whoops. I'm going to bring this triangle down here. Now, let's write all the trig functions that we need from this triangle. Okay, so first of all, we know that the tan of theta is x. Okay, so tan theta, x over 1, x. Sine theta is the opposite side over the hypotenuse, so 1 plus x squared. And we know that the cosine theta is the adjacent side over the hypotenuse. Okay, now the reciprocals of those. The cotan of theta is 1 over x. The reciprocal of the sine is the cosecant, so that's going to be the square root of 1 plus x squared over x. And the reciprocal of the cosine is the secant of theta, so that's going to simply be the square root of 1 plus x squared. Now all we have to do is substitute the necessary trig functions back in, and we'll have our answer to this integral in terms of x. So I'm going to put it in blue. Okay, so the answer is, let's just write this again, 1 plus x squared over x dx equals, okay, tan theta is x. Cosecant theta is the square root of 1 plus x squared divided by x. Okay, then we have plus the natural log, absolute value, because natural log, of course, is not defined for negative numbers or for 0. So we're going to have cosecant theta is the square root of 1 plus x squared over x minus the cotan 1 over x plus c. Okay, and there's our answer, and we're just going to simplify it a little bit. So we're going to say that, of course, these x's cancel. And so we've got the square root of 1 plus x squared. Now remember, the natural log, there's no distributive law for natural log. So you're not going to say, you're not going to say it's the natural log of this term minus the natural log of that term. That would be wrong. But what we can do here is we can combine this to be 1 plus x squared minus 1 all over x plus c, and that is the answer. Okay, so this was a particularly difficult one, and but that's okay, we got it done.